Good evening, ladies and gentlemen. Tonight's lesson is adding fractions using the algorithm. So our goal is that we're going to add fractions just like we did in the last lesson, but this time we're going to move into the standard algorithm. Now the pictures or the visuals or area models that we used in the last lesson are great. The only problem is they're kind of time consuming and they work really well with small numbers, but imagine having a really large number or really large denominators where you have to cut the holes into maybe 20 pieces or 16 pieces. It could get to be a lot of work. So we're going to start the algorithm. Okay, we do have some new vocab this week. Our first vocab is called the LCM. Okay, the LCM stands for something called the least common multiple. Now, we had the GCF earlier. That's something different. This is completely different, even though it's going to look a little bit similar. Least common multiple. Okay, so the least obviously is going to be our smallest. Common is going to mean shared. And now we're doing something called multiples. Okay, so when I think of multiples, I think of multiplication. So for 5 and 3, we're going to list out our multiples. So I'm going to start with 5. Well, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. Okay, I could keep going on and on with 5s. It will never end. It actually can go on for infinity. I'm only going to go, though, as far as I think I need to. So I might just pause right there and then see if I need to go on more. Okay, now I'm going to list my multiples for 3. So I'm thinking in my head, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Ooh, I'm going to stop. Notice I found one. I found a common one. I found 15 to be a common one. Is there anything smaller than that they had in common? Nope. And I wanted the least one, the smallest. So the least common multiple for 5 and 3 is 15. Okay, let's try another one. Okay, 6 and 9. So I'm looking for multiples, so I'm going to do my multiplication tables. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. Maybe I'll stop and see if I went far enough. Okay, now let's list them for 9. 9 times 1 is 9. 9 times 2 is 18. Ah, I found it. I found something they had in common. And there's nothing smaller. So my least common multiple for 6 and 9 is 18. Now let's try another one. 12 and 6. So ready? 12 times 1 is 12. 12 times 2 is 24. I'm actually going to stop because I know 12 is going to work. 6 times 1 is 6, and 6 times 2 is 12. So my least common multiple is 12. Okay, another abbreviation is LCD. Okay, LCD stands for least common. D stands for denominator. Okay, so the LCD is the same as the LCM. They're exactly the same. Okay, you find the least common multiple, and then you can use that as something called the least common denominator. And we'll be practicing that a lot. Okay, this next part is kind of just like a little trick that I want to teach you. Okay, something called Biggie Smalls. Well, this was kind of a lot of work. Not so hard, but a lot of work. You're going to see kind of this trick. When you're trying to find the LCM or the LCD, this is a good trick to look for. So I'm going to find my LCM for 3 and 6. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 6 times 1 is 6. And notice that I found it. It's 6. What Biggie Smalls means is if the small number fits into the big number, the big one is your LCM. So you could save yourself time and not do the work and say, wow, 3 fits into 6, so my LCM must be 6. The same with 2 and 4. Because 2 fits perfectly into 4, I know the LCM is going to be 4. That's a nice shortcut. So notice up here where we did all the work, 3 doesn't fit into 5, so 5 is not my LCM. 6 doesn't fit perfectly into 9, so 9 wasn't my LCM. But 6 does fit perfectly into 12, which means I could save myself time and I could just say my LCM is 12. So it's just a nice shortcut, and it'll usually work about a third of the time, or at least maybe 1/4 of the time you'll see a problem where you can use that shortcut. Okay, so Biggie Smalls is just a shortcut to help you find the LCM, which is our LCD. Okay, notes is just a quick reminder to ourselves how to change improper fractions to mixed numbers. So if you end up with something like 9/5, we can't leave that. Remember, that's improper. A 9-year-old should not be on the back of a 5-year-old. Or a 9-pound box should not be on top of a 5-pound box. Remember, it's not proper. We always put little things on top. So remember, we use in and out. And we divide. So 5 can fit into 9 once. 1 times 5 is 5. And I get 9/5. 9/5 is the same as 1 4/5. They're equal. So quick reminder. Now if it was a whole number in front, if I had 2 and 5/3, I would do the same thing because a 5-year-old should not be on the back of a 3-year-old. That's improper. So I'm going to do in and out. And when I do in and out, I get 1 2/3. But I can't forget about that whole 2. So I actually have 2 and 1 1/3. So my answer would actually be 3 2/3. Okay, that's just a quick reminder that you'll probably need to be using that in some of these problems. Okay, so what are our steps for this lesson? Okay, step 1 is you're going to set up your problem vertically. Vertically looks like this, up and down. So you're going to set up your problem vertically. You're going to find the LCM of the denominators. You're going to find the LCM of the denominators. So when you do that, you have 2 choices. You can list out your multiples, or you can use the shortcut, if it works, Biggie Smalls. I would try the shortcut and check it. Once you've found the LCM of the denominators, you're going to need to do some work to that. What you're going to be doing is you're going to do a lot of steps, and I'll show you that, though. We're not going to list it all out because it's too much to memorize. When you're done and you now have the same denominators, then you're going to add. Okay, you always do fractions first, and I'll kind of show you why. Okay, once you have your answer, no improper fractions are allowed. So remember, you're going to use in and out to fix them. And then you can simplify using the GCF. Okay, remember these notes are just for you to refer to get some help while you're working. Okay, so what does this really look like? Here's my first problem. Okay, I have 1/2 plus 1/3. So I'm going to set it up vertically. 1/2 plus 1/3, and that's vertically. Now I'm going to look and I'm going to find the LCM of the denominators. Here's my denominators. Okay, well, I wish I could use big E smalls because it would be nice, but 2 doesn't fit perfectly into 3. My small one doesn't fit perfectly into my big one, so that's not my LCM. So I'm going to need to do that work. I'm going to need to list my multiples. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. You might already start to know what it's going to be. 3 times 1 is 3. 3 times 2 is 6. And I found my LCM, which is the same as my LCD, is 6. Okay, so remember I said step 2 is going to be a lot of work. I know my least common multiple, which is going to be my least common denominator. That's what needs to be my denominator. Okay, the reason for that is I want you to stop. I'm going to pause doing this, and I'm going to show you when we did this using the area model, what it looked like. When I did this using the area model, I had, and I'm going to move my paper down a little bit so you can see it. I would have drawn 1/2, and then remember I would have shaded it in, and then I would have drawn 1/3, and I would have shaded that in also. But then what I had to do next is I had to make them match. And when you make them match, the reason is because you need the denominator to be the same. You need them both to be cut into the same pieces. Otherwise, it's adding 2 very different things. So when you're adding, they have to be the same size. So what I'm doing up here is exactly what I did down here. I'm making them have the same denominator without doing the pictures. Okay, I'm just going to finish this to see how we'll get the same answer. So remember, next I would have crossed these off and moved them here. So let's see. I'm thinking my answer is going to be 5, 6. Let's see when I do it up here if I get the same answer. Okay, so now how am I going to get my new numerators though? Well, I'm going to ask myself, what did I do to 2 to turn it into a 6? I multiplied it by 3. Well, I'm going to multiply that by 3 as well. So 1 times 3 is 3. Okay, down here, what did I do to 3 to turn it into a 6? I multiplied it by 2. So I'm going to multiply my numerator by 2. Okay, before I had moved these ones over, look what ended up. Didn't I have 3 6 here, and didn't I have down here 2 6? So do you see how this is the same idea? It's just now with numbers instead of pictures. Okay, so I did step 2. Now I need to move on to step 3. I'm going to add the fractions first. Well, I don't have whole numbers, so I'm just going to add my fractions first. Okay, now when I add the fractions, just like down here in the picture, I don't add the denominators, I only add the numerators, because the pieces are, I had 3 pieces plus I have 2 pieces, which means I have 5 pieces out of the 6 it was cut into. So you're never adding your denominator, you're only adding your numerators. Okay, we can come up here to our notes and we might want to write a little note to that. We could even say numerators only. Okay, so when we add, we're adding our numerators only. Okay, next, my next step says no improper fractions. That's not improper, so I can leave it. My next step says simplify using the GCF. Well, here is a really good hint to you. Remember, when I simplify, I could list out my factors and divide by the GCF, but there's actually other ways. So I could simplify using the GCF, or if you remember from the last lesson, there was a few other hints I said. One is that if there's a 1, it can't be simplified. Well, here there's not a 1, but because they're 1 apart, that's another hint. Anytime they're 1 apart, they can't be simplified. So that means I'm done. My answer is 5, 6. Okay, let's try another one. So let's get my steps ready. And here's my next one. If I need 1 3/4 cups of sugar for the cookie recipe and 1 2/5 cups of sugars for the scone recipe, how much sugar do I need? Okay, so I'm going to set up my problem vertically. 1 3/4 plus 1 2/5. Okay, what do I do next? Next, I'm going to find the LCM of the denominators. So, oops, I should have been in red. Sorry about that. Find the LCM of the denominators. Okay, so will biggie smalls work? Does my small one fit perfectly into my big? Shucks, nope. So I have to list out my multiples. So let's come over here and list out my multiples for 4 and 5. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24. Okay, let's hope that's enough because I ran out of room. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. And I just found my LCM, which is the same as my LCD. Okay, so I'm on step 2, that long step, which means my new denominator is going to be 20. Just like when I cut them up, I would make them have the same denominator. Okay, so how did this denominator change into this denominator? How did 4 become 20? Well, 4 times 5 is 20, which means 3 times 5. I'm going to do, notice how I'm making these really small. 3 times 5 is 15. Okay, how did this denominator of 5 become a denominator of 20? I multiplied it by 4. So I'm going to do that here as well. 2 times 4 is 8. Okay, so I've finished step 2. I found the LCM and made them have the same denominator. Now I'm going to do step 3. Add fractions first and numerators only. So the reason I start on the fraction side is think about when you do normal adding, how do you always add? Well, if the number was something like 24 plus 13, I always start on the right side. So I would say 4 plus 3 is 7. I would start over here. So I'm going to do the same when I add these. I'm going to start on the right side. So 15 pieces or parts plus 8 parts is 23 parts out of 20. 1 plus 1 is 2. Okay, so I have 2 and 23/20. Let's look at our next step. Now, no improper fractions are allowed. Okay, this is improper. So I'm going to use in and out and fix it. My 20 is going to go outside. My 23 is going to go inside. 20 can go in once. And I'm getting 1 3/20. Okay, but I can't forget about my whole number. So it's actually 2 and 1 3/20, which gives me 3 3/20. Okay, now my next step says simplify using the GCF. Will any of our tricks work? Let's see. There's not a 1, and they're not 1 apart. Another nice trick is if the small one fits into the big one, you could divide by the small, but that's not working either. So I guess I have to list out my factors. 1 times 3 is 3. 2 doesn't work. If you're getting good at this, you might realize 3 isn't going to be a factor of 20. So 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. So really, because 1's the only common factor, I can't simplify it. And that is my answer. Okay, it's a lot of work. Let's try one. Okay, so our first one is 1/4 plus 1/12. Okay, so I'm going to first set it up vertically. Next, I'm going to find the LCM of the denominators, so 4 and 12. Now, remember up here it says I could try this trick biggie smalls. Does my small one? Oh, I set that problem up wrong. Oh, I'm so sorry, ladies and gentlemen. 1/4 plus 1/3. Okay, so I'm going to now find the LCM of the denominator. So 4 and 3. So 3 doesn't fit into 4. The small one doesn't fit into the big one. So we need to list out our multiples. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And I just found it. It is 12, which means we're going to now rewrite it as the denominator of 12. Think about the area model. This is when you added those lines to make them match. Okay, so how did the 4 turn into a 3? How did this denominator become a 12? I gave you the answer. It was multiplied by 3. So I'm going to multiply those by 3. How did this denominator of 3 turn into that denominator of 12? It was multiplied by 4. Okay, so now that I have my new fractions with my common denominators, we're going to add fractions first. 3 parts plus 4 parts equals 7 parts out of 12. Okay, it's not improper, so I can skip that step. And now I'm going to simplify. Do any of my simplifying tricks work? There's no 1. They're not 1 apart. The small one doesn't fit into the big. So you might have to just list out your factors and see. My factors for 7 are 1 times 7, 2 times nothing, 3 times nothing, 4 times nothing, 5 times nothing, and 6 times nothing. If you know your facts well, you probably figure it out. It's not going to work because 7 is not a factor, which means that is my answer. Okay, let's try our next one. Jane ran 2 1/2 miles on Wednesday and 4 3/4 miles on Friday. How far did she run altogether? Okay, which means they want me to add the miles she ran on the 2 days. So step 1, let's set it up vertically. Step 2, let's find the LCM of the denominators, 2 and 4. Finally one we can use our shortcut for. 2 fits perfectly into 4, which means I don't need to list out my multiples. 4 is going to be my LCM or LCD. So let's rewrite it with the 4. How did this 2 denominator become a 4? It was multiplied by 2. So 1 times 2 is 2. How did this denominator 4 become a 4? really nothing. It was just multiplied by 1. So I get 3. Okay, now we're at step 3. I'm going to add fractions first. So I start on this side. 2 parts plus 3 parts equals 5 parts out of 4. 2 plus 4 is 6. Okay, no improper fractions allowed as step 4. And this is improper. So let's use in and out. So 4 can go into 5 once. And I'm getting 1 and 1/4. Okay, but remember, we can't forget about that 6. So it's 6 and 1 and 1/4. So it's really 7 and 1/4. Okay, I know that can't be simplified because you can't make 1 simpler. So my answer is 7 and 1/4 miles. Okay, that was our longest video ever. All right, you still have 2 problems to try on your own and your homework. Have a nice night, guys.